All right, guys, lesson 2.5. We're talking about the product and the quotient rule. So 2 new shortcuts for you today. 2 different rules that you can use instead of having to do the great big limit definition and FOIL things out. So first rule is called the product rule. So what if you are taking the derivative of 2 functions that are being multiplied together? Now, the formula, I'm going to actually change it that you have right here on your paper, but I want to show you that, again, this is one of those things. It's going to drive some of you crazy, especially those of you future engineers, because you don't care about why things work. You just want to use them. But I want to show you how to build this rule, and then you are welcome to use it. So here's what I want to prove. The product rule. So I want to know what happens when I take the derivative of f multiplied by g. And I'm using some shorthand here. What I mean by f is f of x, and what I mean by g is g of x. So what happens if I want to take the derivative of these 2 functions that are being multiplied together? So let's go ahead and get started. So let's take f of x times g of x, and we are going to take the derivative prime. So using my formula, my limit formula, I'm going to take the limit as h goes to 0. Now remember, I have to replace my x's with x plus h. So this is going to become f of x plus h multiplied by g. I don't need to put the multiply there, right? You guys are smart. Multiplied by g of x plus h. And then I have to subtract f of x times g of x. And then all of that is going to get divided by h. All right, so far so good, right? Not too big of a deal. We are going to, there's this guy, you may have heard of him before, Mr. Newton. Newton came up with a really cool trick where in the same problem, I'm going to add and subtract something. I'm going to add something in, but because I'm adding it in, I also have to subtract it. So I'm going to rewrite this, the limit as h goes to 0. I'm going to keep the beginning the same, f plus x plus h, g of x plus h. But right here, I'm going to insert something, okay? I'm going to subtract f of x times g of x plus h, okay? Now, if I subtract that, I can't just subtract that. I'm going to counter what I just did by adding f of x times g of x plus h. All right, so I haven't broken any rules. I subtracted it. Now I'm adding it back in, okay? And then I have my minus f of x, g of x. So right in the middle of this numerator, I just subtracted something and added it back in. All of this is being divided by h. All right, here's what I would like to do. I want to look at this piece right here and this piece right here kind of separate. All right, if you notice that in the first one, both of those terms have a g x plus h. So I'm going to rewrite this. The limit as h goes to 0. I'm going to take that g of x plus h and I'm going to factor it out. So I'm left with an f of x plus h minus an f of x. Okay. Are you all right with that? I just factored out this from both parts. Now I'm going to do the same thing with my second group. But this time I'm going to factor out an f of x. Okay. So I've got plus f of x multiplied by, I'm left with g of x plus h minus g of x. All of this divided by h. Holy smokes. Okay. Haven't broken any rules. I added something and subtracted it at the same time, and then I just broke my equation into 2 different parts and factored out. All right, so Now what I want to do, I want to use my limit rules. Remember, the limit of one function plus another function is the same thing as the limit. You can take the limits of them separately, okay? So we're going to rewrite this we're going to break this up into two different limits. So I'm going to say the limit as h goes to 0, and I'm going to start with this one, g of x plus h, multiplied by f of x plus h minus f of x divided by h. And then I'm going to add the limit as h goes to 0 of f of x multiplied by g of x plus h minus g of x over h. All right, you with me so far? Okay, now I want you to notice something. Well, maybe we'll break this up one more time. Do we want to break it up one more time? Or can you handle... yeah, let's break it up one more time. I don't want to do too much in our head. But what I'm going to do now is I'm going to take each of these limits and I'm going to split it up again. I'm going to take the limit as h goes to 0 of... What just happened? Of g of x plus h multiplied by the limit as h goes to 0 of f of x plus h minus f of x over h plus, whoa, easy guys, plus the limit as h goes to 0 of, let's see, over here I've got f of x, and then I'm going to multiply by the limit as h goes to 0 of g of x plus h minus g of x over h. Okay, so I have 4 different limits here. I've got this one, my blue one, I've got my red one, I've got my yellow one, and I've got my green one, okay? So I'm going to add some, we're going to actually evaluate these. So the first one, the limit as h goes to 0, if I plug 0 in, g of x plus h, if h is 0, that just becomes g of x. You okay with that? So that first one just becomes my original, my g of x function. All right, multiplied by the limit as h goes to 0 of f of x plus h minus f of x over h. I can't plug 0 in. But do you recognize that formula? That's my derivative formula. So that whole thing right there is actually just f prime of x. It's the derivative of x. And then I've got this big plus sign. Now my limit as h goes to 0 of f of x, well, there's no h even in that function. That function is just f of x multiplied by the limit as h goes to 0 of g of x plus h minus g of x over h. Now what's this one turn into? Well, that's just the derivative definition, right? G prime of x. So after all of that ugly mess, I end up with my function g multiplied by the derivative of f plus my function f multiplied by the derivative of g. That is a lot prettier formula than using that great big limit definition. And this is the one, this is our bread and butter right here. F prime, the derivative of the first one times g, plus the second one, the derivative of the second one times the first. So what I want you to do, if you haven't fast forwarded already because you don't like proofs, here it's written a little bit different. We're going to rewrite this, okay? F of x, the derivative of f of x times g of x equals f prime of x times g of x plus g prime of x f of x. And I want you to, I know it's the same thing because we're adding, okay? It's the same as the formula we just crossed out. Or you can say f prime times g plus g prime times f. These are the formulas I want you to remember. If you're multiplying two functions together, you take the derivative of the first function and you just multiply it by the second function. And then you add the derivative of the second function multiplied by the first function, okay? You know what? Let's do an example right now. While we're talking about it, let's do example 1. So using what we just learned, f prime of x is going, now please don't get confused. Maybe I shouldn't have used f and g. This right here is my first function, and it's being multiplied by this, which is my second function. So my formula says to take the derivative of the first function. Well, that's just 6x. And then I multiply that by the second function. So 6x times 2x plus 3. Then I'm supposed to add the derivative of the second function. So 2x plus 3, the derivative of that is 2, multiplied by the first function, which is 3x squared minus 2. Now, on the test, if this is an AP free response question, boom, you're done. You stop right there. If it's a multiple choice question, it might simplify it. They might go, 12x squared plus 18x plus 6x squared minus 4, which simplifies to be, 18x squared plus 18x minus 4. Either of those answers works. If you don't have to simplify it, please don't. Just stop. On your homework, I'm not going to ask you to go all the way to the end. If you can write that first line, that's all I need to see. I don't need to see you simplify it all the way down. I had a couple students last year that even with the product rule, a lot of times they did not like to use the product rule. So what they would do is they would actually FOIL, okay, I'm going to show you. They would take 3x squared minus 2 and 2x plus 3, and they would actually FOIL that out. So they would get 6x cubed. Am I writing this right? Yeah, 6x cubed plus 9x squared minus 4x minus 6. So they would FOIL it all together, and then they would take the derivative. So then they would say, okay, so this is 18x squared. So if this is y prime. 18x squared plus 18x minus 4, which is exactly what we just got, okay? Now, sometimes that might be faster. Sometimes the product rule is more fast. Sometimes actually FOILing it together is quicker. It all depends on the problem. We've already done the FOIL practice. So today, I'm going to ask you to practice using the product rule. So on the problems that we do today, I want you to actually use, I think on the homework, it even tells you to try it without the product rule. I don't want you to do that. I only want you using the product and the quotient rules today, okay? All right, which brings us to the quotient rule. The quotient rule is the reason why I had you rewrite the product rule. So if you look at the quotient rule, if I have a function on top and a function on the bottom, I take the derivative of the first and multiply it, or the derivative of the top and multiply it by the bottom. And then I subtract the derivative of the bottom multiplied by the top. So it's almost the same as the product, except you do a minus sign in the middle and you're using top and bottom. But then because it's a quotient on the bottom, whatever was on the bottom, I'm going to square what was on the bottom. Okay. So the way that I like to write it is like this. I like to write f prime times g minus g prime times f divided by g squared, which is kind of what's in the box, right? f prime of g minus g prime of f, and then divide it by g squared. So let's try that on number 2. So y equals 2x squared minus 4x. So this is my f, this is my g. So my formula says f prime. So that's, let's see, so y prime is equal to 4x minus 4 multiplied by the bottom, 2 minus 3x. Then I have to subtract the bottom, the derivative of the bottom, which is what? Negative 3, and multiply that by the top. 2x squared minus 4x plus 3. So I've got the derivative of the top times the bottom. Then I have the regular top multiplied by the derivative of the bottom, right? And then all of that is divided by the bottom squared, 2 minus 3x squared. And I promise you, promise you, if this was the AP test, this would be a free response question, and you're going to stop right there. The free response, the multiple choice part of the test is where you have to worry about simplifying things to make it match the answers. They are not going to make you simplify this because look at all the places you would have to FOIL the first two, then you'd have to distribute the negative into the second one, then you would have to distribute the negative into that entire thing, then you would have to combine like terms on the top. On the bottom, you would have to FOIL. Then you would have to look for things that would cancel. Guys, this is a huge mess of a problem. It's not going to ask you to simplify that, at least not on the multiple choice. And if it was on the free response, you're done. You stop right there. You don't try to simplify anything. All right? Okay, number 3. Y equals negative 9 divided by 5x squared. Okay, so we have a top and we have a bottom. So y prime equals the derivative of the top. Well, that's 0 multiplied by 5x squared. Then I have to minus the derivative of the bottom, which is 10x, multiplied by negative 9. Does that look like negative 9? And all of that is going to be divided by 5x squared squared. So again, if this was the free response, I would stop right there. If it's multiple choice, this one's not as messy because 0 times anything goes away. The second part, negative 10x times negative 9, that becomes 90x. On the bottom, you have what? 25x cubed. So that simplifies to, let's see, the x's are going to go away. The x's are going to cancel each other out, so I'm going to end up with 90 over 25x squared, and 5 divides both of those, so I end up with 18 over 5x squared. Cubed, what am I doing? That's not a square. This is like something doesn't look right. This is a fourth. This is a fourth. Nope, because I canceled it. So this becomes a cubed, and this becomes a cubed. So I should have 18 over 5x cubed. Okay. If you were to do this using the old method, what you would do, and maybe I'll do this and again, I don't like doing this on this homework, but before you would have had to do this, negative 9 over 5 times x to the negative 2. So y prime would be, negative 2 would multiply, that would be 18 over 5 x to the negative 3, which becomes 18 over 5x cubed. Same answer, right? This is one of those that the first way that you learn to do it is probably faster. On this homework, I still want you to try using the quotient rule, okay? That's the kind of problem that on the test, you can make the choice. But on this homework, I want you to practice using the quotient rule that you learned. All right, number 4, g of x equals 3e to the x multiplied by sine of x. This one might be a little bit hard to see the two different functions, okay? You've got 3e to the x, that's one function, and you have sine of x. So g prime of x, the derivative of the blue, that's just 3e to the x multiplied by the second one. Well, that's just sine of x. That's interesting. Anytime you're taking the derivative of something with an e in it, it never gets nicer. Derivatives with e's just get bigger and bigger and bigger because every new term, remember, e to the x is the derivative of e to the x. So now I have to add the derivative of the second one. So the derivative of sine of x is cosine of x. And I have to multiply it by 3e to the x, the first one. And again, I can stop right there. I'm not going to worry about factoring out a 3e to the x. This is going to, I'm done right here. This is where I stop. All right, on the homework. Okay, couple of things I want you to know. This homework, again, number 2, first of all, I want you to do all of them. So the homework for 2.5 is to do all the problems. Number 2, see how it says to differentiate without using the product rule? No, I want you to use the product rule. Just kidding. That's the same as number 1. Do I want you to do it that way? Yeah, go ahead and let's do what they say. Let's FOIL that out, solve it. You're going to hopefully get the same answer if you're doing it right because it's using the same one. I don't know why the number 3 and 4, yeah, I mean, we can try it both ways. All I care about is that you actually get the answer. So number 4 is going to have you move this to the top and then multiply it. Anyway, you'll figure out number 4 because that one can actually be simplified first. The top reduces, the bottom reduces, and you can simplify that before you take the derivative. The rest of these, you can differentiate however you want. Once you'll notice this homework is pretty long. It's giving you example problems from earlier homeworks, but now that you know the product rule and quotient rule, you can use that within the problems, okay? So for example, you're gonna run into some of these like number 21. Now that you know the product rule, you can find h prime using the product rule. Use that as you do these problems. Again, I know it's a longer homework, but these are all review topics that I need you to get better and better at. And you don't get better if you don't practice it. So we will see you in class next time.